Okay, now that we have two fractional problems under our belt, I think you should shut off your video and try 4 and 5 on your own before you watch and see mine. That way it'll kind of give you an idea whether you're good with these. This is either number 1 or number 2 on your test, so you do have to know how to do problems with fractions in them. So if you haven't tried a couple on your own yet, go ahead and do that and then come back and join me. So this first one kind of looks like the one we did on the last page. We look at the denominators, 2, 10, and 5. I pick the largest one and I say, can 10 be the LCD? Does 2 go into it? Yes. Does 5 go into it? Yes. And remember, this denominator is 1, so it goes into everything. So this one is going to have 10 as the LCD. So in every numerator and beside every whole number, I'm going to write 10. And if it helps you to extend the numerators a little bit, just to know that first you multiply, then you can divide, or vice versa, it doesn't really matter. So we can see this first term is going to be negative, and 1 times 10 is 10. Divided by 2 would be negative 5y. So this is half of 10, which is 5, and it's negative. And then we have plus 40. And just like on the last page, when the denominator matches something in the numerator, anything divided by itself is just 1, so you can just cross those out. So that leaves negative 9y. And here we have 20 divided by 5, so the fraction bar just means division, so 20 divided by 5 is positive 4. And now we just have a nice, pretty problem, no fractions. So we're on step 2 that says, take all your variables and move them to the left. So I'm crossing the equal sign, so I have to do the opposite. So add 9y, add 9y. And so that's going to leave me 4y plus 40. So 9y minus 5y is 4y plus 40 equals, this cancels, which it's supposed to. It's supposed to be 0 because you're bringing it over there, equals 4. And then one last step before dividing. Anything without a variable goes to the right. So do the opposite to move it. The opposite of add 40 is subtract 40. So when the signs are different, the rule is to subtract and keep the sign of the larger. So we have 4y equals 40 minus 4 is 36. Keep the sign of the larger. And then our last step, as I said, is almost always division. The opposite of times 4 is divide by 4. So we get y equals negative 9. One negative in division is negative, and a negative divided by a positive is negative. So that was very similar to number 2 on the other side. I think they just changed one of the fractions. Okay, let's go ahead and try this next one. So again, I'm going to write it big so I can see my canceling a little bit better and not lose signs, because I see sometimes students trying to write it in up there. They lose signs, they lose X's. So I think it's really nice to be able to write it big first, and then it's a little bit easier to work to. Okay, looks like I copied everything right. So now let's look for the denominator. So we have a 5, a 3, and a 2. So 5 doesn't work because those two don't go into 5, so I start doing multiples. 5 times 2 is 10. 3 doesn't go into 10. 5 times 3 is 15. Yes. Oh, 2 doesn't go into 15. 5 times 4 is 20. No. 5 times 5, 25. No. 5 times 6, 30. Ding, ding, ding. So 30 is the common denominator for that one. So you just take the largest number and start doing multiples. And that's how you can find the common denominator. So notice how these are different than the ones we did above, because up here we just had single terms in the numerator. Now we have two terms, two terms, two terms. So when you go to put your 30 in, the LCD, you need to put parentheses here, 30, and then just expand that. Put parentheses here, 30, and put parentheses here and 30, and then we can make that longer. So in this type, when there's two terms in the denominator, it's actually easier to divide first, because otherwise you have to distribute and then divide everything by 2. Distribute, then divide everything by 3. Here you just do it in one step. So you say 2 goes into 2 once, 2 goes into 30 15 times. And you go down the line and do that. 3 goes into 3 once, 3 goes into 30 10 times. 5 goes into 5 once, 5 goes into 30 6 times. So now you're going to distribute that new number, and you don't have to distribute then divide. So now you just work with a lot smaller numbers. So this one's going to have the 15 distributed. So 15 times 3x is going to be 45x minus 15 times 7. I think that's 135, but let's verify. 105. Good thing I did verify. Minus 105. And then we're going to distribute the 10 plus 30 minus 50x equals, then we're going to distribute the 6. 6 times 3 is 18 minus 36x. So since we did a lot of work on that step, let's just check it again real quick. So 2 goes into 30 15 times, 3 goes into 30 10 times, 5 goes into 30 6 times. So 45x minus 105, 30 minus 50x, that's right, and then equals 18 minus 36x. Looks good. Okay, so after you remove parentheses, which we just did, remember the next step on the box on the front page was combine like terms. So we remove parentheses, remove fractions, then we combine like terms. And I see 2 sets of like terms over here. Here's one set, and then I have another set. So like terms means they have the same variable or the same lack of variable. So positive 45 and negative 50 would be negative 5x. Because again, the signs are different. So you subtract and keep the sign of the larger. Larger. And here again, the signs are different. So we can do this one. Negative 105 plus 30. Negative 75. So negative 75 equals 18 minus 36x. So, looks good. We have one x on the left, one x on the right, one number on the left, one number on the right. So that tells me I'm ready to start moving things from left to right. So let's go ahead and bring it up here so we have some more room. So negative 5x minus 75 equals 18 minus 36x. So first we want all of our x's over to the left. So to move that 36x over, I have to do the opposite. The opposite of subtract 36x would be add 36x and put it underneath its like term. And so now we have 36 minus 5, which would be 31x minus 75 equals 18. And 36 minus 36 is gone. Then we add 75, add 75. So that would be 31x equals 1393. So divide both sides by 31 because that's the opposite of multiplying by 31. And we just get 3. So that one worked out nice, huh? And if we wanted to check something ugly like that, you would kind of just plug it in and do each fraction separately. So if you plugged 3 in here, you get 9 minus 7 is 2 over 2. So like if I were writing it down, I'd go, oh, okay, 2 over 2 is 1, right? So I put the 3 in. 3 times 3 is 9, minus 7 is 2. 2 divided by 2 is 1. So I would just keep track of it here as I do my check. We don't have room, so that's why I'm doing it on this separate sheet here. 3 minus 15, because 5 times 3 is negative 12, divided by 3 is negative 4. And then, let's see what we get on the next time. 6 times 3 is 18. So 3 minus 18 is negative 15 over 5 is negative 3. So negative 3 on the left, negative 3 on the right. Boom. So even though it's super, super, super ugly, I can still check it easily. All I did was take my 3. Let me try to get it all in the picture. I just took my 3 that we found here and plugged it in and did it in my head. 9 minus 7. 2 divided by 2 is 1. And then I took the 3 that we found, plugged it in here. 3 minus 15 is negative 12 divided by 3, negative 4. And then 18, 3 minus 18 is negative 15 divided by 5, negative 3. This side gave me negative 3, that side gave me negative 3. So with just, your checks don't have to be formal unless they ask you for them to be formal. So you can just do a little spot check just like I did. Okay, next we have decimals, and you're going to see decimals follow the same rule as fractions. Guess why? Because every decimal can be written as a fraction. Because 0.2 is really 2/10. 53.6 is really 536 over 10. So the common denominator would be 10, and you would multiply everything by 10. So you'd put a 10 here, you put a 10 here, and you put a 10 here, and you get gone, gone. And so you get 2x minus 536 equals 10x. So anytime there's one decimal, you take the decimal out and it goes over 10. One decimal, you take the decimal out and it goes over 10 because this is read 2/10. 53 and 6/10. So you take the decimal out when there's one decimal place and put it over 10. If there's two decimal places, you put it over 100. 3 decimal places, 1,000. So same process works for decimals as fractions, and we do usually remove decimals just because like students try to combine these and it's confusing. This is 1x, this is 0.2x. So we recommend just get rid of the fractions and decimals first and then look at your nice pretty equation you have to solve. So if you don't want to do the step where you write the tens in, just remember that it would be 10. So 1 decimal place 10, 1 decimal place 10, 1 decimal place 10. So every one of these terms needs to be multiplied by 10. So let's write it big again. And then I'm going to show you a little trick of the trade, which you might remember from previous classes. When you multiply a number by 10, it moves the decimal place. It doesn't add a 0. Students always think, oh, add a 0. No, it moves the decimal place 1 to the right. So watch. If I multiply 0.2